Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 12C assignment. First one we're going to take a look at here is number 1. Stone is thrown from a bridge with initial trajectory 25 degrees above horizontal. At the time when it has traveled x meters horizontally, the height of the stone above the water under the bridge is given by h of x equals ax squared plus bx plus c meters. Stone is thrown from 3 meters above the water. So we know that this is 3 meters right here. And it reaches its max height when x equals 5. State HO and hence find C. So for A, HO, that's when time is 0. So that's right when it's leaving the person's hand who's throwing it, right? See, if the stone is thrown from 3 meters above the water, HO has to equal 3, and it says, and hence find C, because really if you look at this this thing here, H of 0 equals AX, but X we now know is 0, A0 squared plus B times 0 plus C. That turns into 0, that turns into 0. We already know that this really over here is, that's 3, right? So we know that 3 is C. So now instead of that C, we're going to put a 3 in there. Okay. Find H prime of x. So find the derivative of x. Okay. So we've got, again, h of x is ax squared plus bx now plus 3. So h prime of x is going to be what? 2a x to the first plus b, and then the x's are gone, and then the constant's gone. So it should just be 2ax plus b. Okay. Part C, explain why the derivative at 0, when time is 0, equals the tangent of 25, and hence find B. So this is part C. So if you'll remember, the derivative at 0, that's going to give us our slope, right? So H prime O is our, we call it gradient, otherwise known as slope, right? And really, if you look at this here as, here's our triangle. Let's maybe redraw this here a little bit to make it make a little bit more sense. So we've got, make this into a right triangle here. Here's our trajectory angle at 25 degrees. And if you'll remember, slope is rise over run. In this case, the rise is the opposite, and the run is the adjacent. And guess what? That's what tangent is. So that means that that equals the tangent of 25 degrees. Okay? So that's what's going to make our B here tangent of 25. Because if we use this formula here, we got h prime of x, in this case h prime 0, our derivative, equals 2ax plus b, right? We know that this here is going to be the same thing as tangent 25. And then when we got 2a and we plug 0 in for x, that's gone. So therefore b has to be tangent 25. Okay, so now we've got the b and the c. Okay, and then part D, find the value of x when the stone lands in the water. So what we want to do here is, here's our key piece of info here, is that it reaches its maximum height when x equals 5. Okay, so it reaches its max height right up here when x equals 5. Now, remember, when it's at its max height, we know that the slope of the tangent is going to equal 0, right? So that means, remember, slope of the tangent is the same thing as derivative, so derivative equals 0 at the max height. Okay? So we know the derivative at 5, our slope is going to equal 0. Okay? So then what we can do is then now we can plug in the info from here with our b and our x and our c, all that kind of good stuff. Our derivative over here, let's see, we now know that b is tan 25, right? And then we can use that info to help us figure out this other part being a. We should be able to figure out what a is since we know that b is tangent 25. So let's do this. We know that 2a, and then we're plugging in 5 for our x, right? Plus tangent 25 has to equal 0, right? And that's from this info here. Okay, because the derivative at the max height is 0. So this is 0 equals 2a. We're plugging in 5 for x because that's, we know when x equals 5 is when it's reached its max height. Okay. So then now what we're going to want to do is try to solve this thing here for a, right? 2a5, that's 2 times 5 is 10a. And then let's do this. Let's subtract tan 25 minus tan 25 gives us that 10a equals negative tangent 25. Divide both sides by 10, and we get that a is going to be negative tangent 25 over 10. Okay. All right. So now that we know what a, b, and c are in this equation up here, we can now rewrite this and figure out when our, if we're trying to figure out the value of the stone when it lands in the water, we know that our height is going to end up equaling 0, right? Okay. So we're going to rewrite all of our new formula here. So h of x equals negative tan 25 over 10. Let's see, x squared plus b, which is tan 25, x plus 3. That's our formula there, right? Okay, so what we're going to want to do is we're going to plug this into the graphing calculator and figure out when it equals 0. Okay, so let's clear that stuff out here. Move that over. Ooh, I don't know why. Oops, sorry. I don't know why that happened. Okay, so let's clear this stuff out. Okay, so here's what we're going to do. We're going to do y equals. We're going to put this lovely equation in here. I'm going to put this in as a fraction, so I'm going to do alpha y equals should give me my fraction piece, and it does. So I'm going to do negative tangent 25. Close my parentheses there, divided by 10. And then times x squared plus, and that's going to be negative tangent 25, right? Or no, wait, sorry, that's just plain old tangent 25 because that's what b was. B is tangent 25, so just plain old tangent 25. Close the parentheses, and then plus 3. Okay, and then we can graph this, but first I'm going to make sure that my mode is in degrees, which it is. Super important to have that, otherwise it's going to be awful. This graph is still probably going to look a little weird, I would imagine, at the beginning here. So look, it's showing that here's negative time, right? And here's our rock. I'm gonna pause this for a second while this calculator slowly graphs this thing. Okay, so here we go. We don't even have to zoom in. This is good enough to see what we need. So here's the rock being thrown up. Although look, it's not going up when time is 0, so that's a little concerning. Let me double check something here. That's what I forgot. I did plus tan 25, but I did not put the X at the end, so I'm going to go over here. Instead of redoing the whole thing, you can actually just go to the spot that you want and then do second insert. And then I'm going to get let's see, X. Okay, I got that backwards, so I want to do parentheses now and then X. And then plus 3, and now we should be in better shape. Okay, so here's what it looks like. If you want to see that thing over here go until it hits the x-axis, all you want to do is just hit the window, and our x scale needs to be, we need to go to a higher maximum, so we want to go, let's just say 20, and see what that does for us. Okay, so that's what we get. So here we go. Here's the rock being thrown up at the angle. That looks better. Here's our max out here at 5, which is what it told us. And so we're trying to figure out what this is right here. So to do that, we do second trace, and we are going to find the 0, right? We want to know when this thing equals 0. And so it's simply going to ask us left bound. So as long as this thing is to the left of where it crosses through, we're fine. We push enter. And then we're going to move this, we're going to scroll this thing over until it gets down below the x-axis here, right? So when this x here is going to end up, that has to go into the negatives here. And again, my calculator is going really slow, so I'm going to pause this while I get it over there. Sorry, it's not when the x is negative, it's when the y is negative. So now we know it's down below the x-axis, so it's now crossed through the x-axis, and now it says guess, and it will calculate it for us. I thought I pushed enter, didn't I? Oh, there we go. 0 is at 14.45. So kind of ran out of space here a little bit. Let's move it up. So 14.45 is when h equal, like when when our x value is 0, when our y value is 0, is at 14.45, in this case 14.45 seconds. We back up on that. That is not seconds, but it says that x meters horizontally, so that means at 14.45 meters away from where he released it is when it's going to hit the water. Okay, or she, doesn't say what we got going on here. Okay, so find the value of x when the stone lands in the water, 14.45 meters away from where the stone was thrown. Okay? Okay. Second one we're going to take a look at here is number 4. Concerned with parking, transportation, catering, and all aspects of the local fair, the town mayor decided to model the attendance at the fair using the function blah, 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 where T is the number of hours after 8 a.m. The fair is open from 8 a.m. to 6 p.m. At 10 a.m., the attendance was increasing at a rate of 1,770 people per hour. At 4, the attendance was decreasing at a rate of 1,800 people per hour. State 4 conditions for A of T and A prime of T, the derivative of T, you can deduce from the information given. Okay. Okay, so for part A here, we know before the fair is even open at 8 a.m., and that's hours after 8 a.m., so that's going to be time equals 0. The attendance will also equal 0, right? So we would write that attendance at time 0 would be 0. Okay, we also know at the end, when time equals, let's see, it's open from 8 a.m. to 6 p.m. So that would be what? 10 hours after. Time equals 10. Attendance should also equal 0. So A of 10 equals 0. So that's two conditions that work. And then the other conditions that work are going to be these other pieces that they give us here. So the attendance was increasing at a rate of 1770 people per hour at 10 a.m., which is when time equals 2. So now when time equals 2, the attendance rate is 1770, right? So that's when we would, instead of just being plain old A, that's going to be the derivative of A, right? Because that's the slope. So the slope at 2 hours is going to equal 1770. Okay. Now we also know when time is, let's see, at 4 o'clock, which is what, 8 hours after. So time equals 8. The attendance rate is at negative. It's going down 1,800 people per hour. So that means that A prime of 8 equals negative 1,800. Okay, so for part B, okay, we know that the attendance at time 0 equals 0. So if we plug in this A of 0 equals, using our original formula right up here, A times 0 cubed plus B times 0 squared plus C times 0 plus D, those all turn into zeros. So we know that 0 has to equal D, right? Because we can just simply plug in, instead of that there, we plug in 0. Okay, so we know that D has to equal 0. Okay, and then now we're going to want to go through and see if we can't find out what some of these other, see what A, B, and C will equal. Okay, so we also know that at A of 10, it's also 0. So A of 10, otherwise known as 0, will be A times 10 squared plus B times 10 squared, this is 10 cubed over here, plus 10, and now plus D, since D is 0, we're just going to get rid of that. Oops, I shouldn't do that up there because that'll mess up that part. So there, plus 0, since we now know that D is 0. So we can plug in that, and then we end up getting that 0 will have to equal 10 cubed is what, 1,000 A plus 100 B, oops, that's got a C on the end of it, plus 10C, all has to equal 0. Okay, so there's an equation that we can use here in a bit. Now we're going to use our other information here. So we know what we want to know now is, since we've got some information about the derivatives, let's take the derivative of our original function here. So A of t is AT cubed plus BT squared plus CT. And again, we know that D is 0, so we're just going to leave 0 out of the equation here. And now we're going to, so now we'll take the derivative. So A prime t, or the derivative, is going to be 3AT squared plus 2BT to the first plus C, right? So there's our derivative. So we now know from over here, we've got this info right there. So let's plug that in and see what we get. So we've got A prime of 2 has to equal, we're going to plug in 2 for these t's, right? And we know that it's going to actually end up equaling 1770. So we go 3 a times 2 squared plus 2b times 2 plus c, we know that this actually equals 1770. Okay? So if we simplify this here, 2 squared is 4 times 2 times 3 is 12a. 2 times 2 is 4b plus c equals 1770. So there's another equation that equals 0. Oh, sorry. We don't even really need that part right there, right? In fact, maybe over here we'll set this equal to 0. So we got all of our numbers equal something over there. Okay, and then we can do the same thing for the derivative at 8 equals negative 1800. So we've got, here's our derivative function, which is going to come in handy for this one. So we know that a prime at 8 equals, let's see, 3a times 8 squared plus 2b times 8 plus c, which again we know that equals negative 1800. Okay, so here's a third equation. So we have this equation, and that equation. So now that we have 3 equations with 3 unknowns, I'm going to curl this off and get rid of that for our third equation. So we got 3 equations, 3 unknowns. Now we can plug this in to our graphing calculator and solve it using matrices. Okay, we can solve it using matrices, but I believe the polysymult 2 will be a little bit easier. So let's try that one. So polysymult 2, and we're going to use the simultaneous equation solver. Okay, so we'll enter that in, and we now have 3 equations with 3 unknowns. Oops, I gotta go over here to 3. Decimal, normal, float, all the rest, and we're in degrees, so everything else is good here. So now we push graph for the next, and now we're going to put in all of our lovely equations. So this first one here is 1,000, and then all of our a's are now going to be x's. So you simply push enter, and it's going to go to if that's going to be positive or negative. And then we got 100. Enter, and then in this one is 10. Oops. I just push enter because that's plus, and now we do 10. And then there's no D, and this whole thing equals 0. And we push, I believe, enter. That worked. There we go. And it should, there we go. It kicks us down to the next one. And we're going to enter this one in, and we're going to enter that one in. Okay, I'm just going to pause, put that all in so you don't have to listen to me babble on and on about the numbers. So, of course, I forgot to simplify this one here first. So 64 times 3, that's 192a, plus 2 times 8 is 16b, plus c equals negative 1800. Okay, so then that is what we can put in our last line here. So we end up with this here, and we push solve and cross our fingers and hope that it works. Okay, so we get that our x is negative 7.5. And in this case here, the x is the a, so let's not write x equals. Let's do a equals negative 7.5. B is negative 185. And C is 2600. Okay, so that ends up giving us our function. If we replace A, B, and C, we already replaced D with 0. So that means A of t is going to equal negative 7.5 t cubed minus 185 t squared plus 2600 t. That is our new function. Okay, and then now you can use that function here to solve the rest of the problem on here. So just to give you a hint, for C, you'd want to end up plugging this equation here into the y equals, and then you're going to have to start adjusting your window so you can see that max value, but you should be able to end up finding that max value. Okay, and then for D, using the graph, it will help you figure out what time that is, and then you should be able to take that time and convert it into like it'll tell you how long it takes, so then you can take that and convert it into time. Okay? All right, that's all we have for the 12C worked problems. If you have any further questions, please feel free to ask in class. Thanks.